Hello, my name is Kennedy French. My mentor is Dr. Rhodes, and I'm going to be talking about incorporating probiotics in oral health to prevent antimicrobial resistance. First off, I'd like to let you know I want to be a dentist one day. This is the field that I really just find interest in and that I want to be my career, so this is mainly why I focused on the oral health aspect. While sifting through different studies, I kept finding information on how probiotics help with gastrointestinal health. But there was a gap in the literature on how probiotics can affect the oral microflora. All I could find is how probiotics help with chronic bad breath or decrease dental caries. I was curious how probiotics could impact the bacteria within the mouth. While researching this, I discovered that dentists are among the top prescribers of antibiotics, so I wanted to look at how probiotics affect the level of antibiotic-resistant bacteria within the mouth. First of all, we did a pre-test, treatment, post-test approach. During the pre-test, we obtained a saliva swab from each participant and put it into some TSB broth. We then incubated it. And then whenever it came time to pipette it, we pipetted it into different well plates. For each participant, they had their own well plate. And we applied the 2 different antibiotics to these. Then we incubated it again. So the participants were given yogurt for 1 week after that and instructed to eat it morning and evening. They were also reminded to consume the yogurt twice daily. I actually sent out a text to them via Remind app every day. Then the post-test came around and we did the whole process over again, as in giving them the saliva swab and putting it in the TSB broth, incubating it, and then we applied the antibiotics to it again. So what I did here was include a pictorial of an interpretation of MIC assay results, since this was the research tool I used to obtain my results. This method tests for the lowest concentration of an antibiotic that inhibits growth of bacteria. With this test, we concluded whether probiotic use increased or decreased antibiotic resistance within oral microflora. A MIC assay was completed by setting up a 96-well plate. Within the plate, there were 8 rows and 12 columns. Each well can hold up to 360 microliters. The ranging concentrations in antibiotics will be in each of the columns. The penicillin and cephalexin both had differing working doses, normally found in the body. For example, in column 1 of penicillin VK, there was no antibiotics, but in column 2, there was 0.25 micrograms per milliliter, and it increased by 2-fold until it reached 64 micrograms per milliliter in column 11. Cephalexin was similar in that it started out with no antibiotics in column 1, but there was 0.5 micrograms per milliliter in column 2, and it also increased by 2-fold until it reached 256 micrograms per milliliter in column 11. There was no antibiotics in column 12, which allowed us to compare column 1 to column 12. So let's take a look at this figure. The yellow circles indicate bacterial growth, and the blank circles indicate no bacterial growth. The concentration of antibiotics decreases from left to right on the plate. The graph should be read from right to left. As the concentration of antibiotics increases, the minimum inhibitory concentration is reached and there is no growth in the following wells. A t-test indicates that average antibiotic concentrations are significantly different with a p-value of less than 0.0001 between penicillin before treatment and penicillin after treatment, as seen in Figure 1. A t-test indicates that average antibiotic concentrations are significantly different with a p-value less than 0.001 between cephalexin before treatment and after treatment. The antibiotics were compared to one another at a concentration of 16 micrograms per milliliter for participant 3. Penicillin started out at 5,821.67 absorbance and decreased to 4,498.33 absorbance. In comparison, the absorbance values for cephalexin initially was 3,641.67 and decreased to 2,855. Figure 4 helps us illustrate that the mean p-values were higher in penicillin with a p-value equal to 0.24 than cephalexin with a p-value equal to 0.16. The findings of this study rejected the hypothesis that stated if probiotics were administered daily, then there would be a decrease in levels of antibiotic resistance in oral microflora. We obtained a p-value equal to 0.33. However, we failed to reject the null hypothesis that stated there was no relationship between probiotics and levels of antibiotic resistance in oral microflora. This means that there was no significant difference between probiotics administered and levels of antibiotic resistance. However, there are some important findings to note. There is a significant difference between the initial and final concentration of penicillin in participant number 3. This helps highlight that each individual participant displayed variable results based on many factors. One factor being the variability in microflora among all participants. In addition, how the antibiotics perform within the microflora serves as an additional factor of importance. Another factor was how closely each participant followed the administration instructions. All the participants were properly informed on the procedures. Each participant was given the same instructions and reminded at the same time. There could have been a lack of dedication present, or the participant may have forgotten. Although the results of all the participants combined was not statistically significant, we still see a trend towards decreasing levels of antibiotic resistance in most individuals. At specific concentrations, it was easier to pinpoint the decrease in levels of antibiotic resistance. At a concentration of 16 micrograms per milliliter, the levels of absorption in cephalexin and penicillin decreased from the pre-test to the post-test. The MIC was hard to decipher in most graphs because the bacteria were still growing for the most part. One interesting finding was how in most of the figures there would be a spike in absorbance and then an abrupt decrease in absorbance. However, it would rise back up to a higher absorbance value. This just signifies that there was antibiotic resistance present. Instead of eliminating the bacteria like the antibiotics were supposed to, we saw that the bacteria were still growing. This could have happened as a result of refrigerating the well plates for the length of time we did. We had to initially refrigerate them because we needed to stop the growth of the bacteria until we could get back in the lab. It is within reason to infer that the bacteria survived the refrigeration and kept growing. The mean p-values for each antibiotic were collected from the pre-test and post-test of each participant. There was a process on how to obtain this p-value. The initial absorbance averages from the pretest were compared to the final absorption averages from the post-test. As stated previously, this was completed for each participant and also for each antibiotic. For example, participant 3 had an initial and final averages for penicillin and cephalexin. For penicillin, the p-value was less than 0.001, which means there was a significant difference between the pretest and the post-test. In cephalexin, we saw the same result because the p-value was less than 0.001. After running individual t-tests for each person, we ran another t-test to compare p-values of each antibiotic. We obtained an overall p-value of 0.33, which was not statistically significant. It's worth mentioning the variability of the oral microflora in each participant. According to a group of researchers, patients with diabetes or cancer are far more susceptible to having an altered oral microflora. This is just a small group of people who have a dynamic microflora, and it helps shine light on that. Although many of the same bacteria are found within the oral cavity, there are also some factors that contribute to how the flora works together as a unit. There can be the same types of bacteria in different areas of the oral cavity that help fight off infection. For example, one strand of bacteria on the anterior tongue can help communicate and fight off infection in the middle of the tongue. This can be different from person to person, though. After all, the oral cavity houses one of the most abundant microbiota just behind the gastrointestinal tract. Because of this vast abundance of bacteria, it's worth mentioning that there is a difference of how the bacterial species are spatially arranged. So there are different niches or niches, however you pronounce it, within the oral cavity. A niche includes where organism resides and the organism's function within its environment. Therefore, by introducing differing strains of bacteria from the yogurt into the microflora, these bacteria competed for those resources within the mouth. Due to the variability in each individual's microflora, there was a range of data collected. One study suggested that there were several factors that make up a healthy individual's oral microbiome. These factors, they included the following, such as time, age, diet, extreme environment, plus other things. This study found that differing oral microbiomes can be altered or can be related to gender as well. One interesting finding was that by using gene sequencing, they were able to tell if a patient had been breastfed versus formula fed as an infant. The methodology from this experiment can provide a nice model to future research. Whether it is replicated exactly or modified in some way, it is a different approach than the research models that already exist. A MIC assay was chosen because it is a simple way to see growth of bacteria increase and then almost no growth occur at all. This is how the minimum inhibitory concentration is found. In addition, a MIC assay is a common and easy tool to utilize. So I just wanted to hit on a few mistakes that were made during this experiment. For example, in tray 7, the solution of TSB broth did not get added to the antibiotics. It was overlooked simply when pipetting. This resulted in the absorption reading to be incorrect. Therefore, there was an error in the results. Another mistake was miscalculating the working doses of antibiotics and purchasing too much antibiotics. Although the researcher, me, only had black well plates for the pretest, so the solution had to be transferred into clear plates in order to read the absorption. So by pipetting everything again, some solution could have been left behind. Some future improvements to make would be to calculate everything from the beginning. Also, it is a good idea to autoclave everything in the beginning just to give yourself a fresh start with everything laid out, all the tools you're needing. Additionally, you should probably use some well plates, whoever does this in the future, some clear well plates. Lastly, a shorter refrigeration period is ideal. The long refrigeration period could have allowed the bacteria within the well plates to continue to grow, like we saw. In future experiments, the researcher might consider lengthening the time of the probiotic consumption. If the participants consumed the yogurt for a longer period of time, there's a possibility that the results would be significant. Also, just a larger sample size must be obtained in the future to ensure validity. I was supposed to have 50 participants, but that didn't happen. Ultimately, the whole goal of this experiment was to compare results from a pretest and post-test to see if there was a difference in antibiotic-resistant bacteria within the oral cavity after consuming probiotic yogurt for 1 week. The hypothesis that predicted to see a decrease in antibiotic-resistant bacteria after consuming the yogurt was rejected. If there was a significant difference between the pretest and post-test, then that would have added to the gap in the literature. However, this study still added something to the literature. There were mistakes made and to be corrected in the future. While previous work elucidated that bacterial interactions in the mouth have influences on diverse aspects of our biology, little is known about probiotics and how they will combat antimicrobial resistance. So this study can be a foundation and a future experiment can be performed to see greater results. We failed to reject the null hypothesis, stating that there was no relationship between probiotics and levels of antibiotic resistance in oral microflora. This study did find that there was variability within each person's oral microflora. It also shined light on how antibiotics affect the oral microflora and contribute to antibiotic resistance. Antibiotic resistance is a growing issue globally. Creating a focal point in oral health can be a small way to combat this rising power. Looking back at this whole process, I'm feeling nothing short of relief to finally see the light at the end of the tunnel. The end is finally near, and the next chapter of my life is on the other side of the door, awaiting my arrival. I remember thinking I would never come up with a senior thesis project. I also remember thinking, how in the world am I going to research something that pertains to the field in which I'd like to have a career in one day? So I found the most perfect mentor. Dr. Victoria Rhodes. She's purely amazing and helped me narrow down a topic very easily. It was from then on where we began the journey of finding out if probiotics can help prevent antimicrobial resistance in oral health. Two things I am very interested in: antibiotic resistance and dentistry. I learned about antibiotic resistance for the first time in Dr. Rhodes' microbiology class. It was an interesting topic that spoke to me. Not only was Dr. Rhodes my professor at one point, but she was also my academic advisor. This is what led me to choosing her to be my mentor for my senior thesis. In addition, my interest in dentistry is what made me choose this topic to research. I knew I wanted to center my research around the field I would like to have a career in one day. When I saw that there was a gap in the literature on whether or not probiotics could help the oral microflora, I just had to jump on it. The feeling of joy and relief overwhelmed me when I got word about my research proposal that I had worked so hard on was approved by the honors committee. The feeling of relief was very prevalent because I felt as if I did not do too well during my pitch to the committee. Because I felt poorly about that experience, I began to work on the things within my control. The presentation was something I was in control of. I was fearful I would mess up or be judged. I knew my project better than anyone in the room. I was the expert. However, that sympathetic pathway, or better known as fight or flight response, activated before I had time to think about it. Clearly the fight category was chosen and I froze. Words would not come to my mouth. I remember feeling very nervous and embarrassed because I knew I could have handled the situation much better. After all, I did go over a similar scenario in my head a few times before. This lesson taught me to stay calm and only focus on the things within my realm of control. The IRB approval process was an easier experience than I had imagined it to be. I heard other students having issues with it, but it went rather smooth for me. I had to make a few minor edits, but I was approved in no time at all. When it came time to begin my experiment, I did not have any grants to cover the costs. I did not even know I was approved to receive the grant. I did not even know if I was approved to receive the grant I had applied for. So I went to Walmart to purchase the yogurt. The total was around $210, and I remember thinking I had to get funds to cover this. I needed that research grant. I actually swiped my discount card at Walmart because I'm an employee, and turns out you don't save anything on yogurt. One way to help get participation for my research experiment was by offering a $50 Visa gift card and 10 extra credit points for the microbiology class that the participants were in. I was able to get SMB Bank to donate the Visa gift card, which was super awesome and helped me out tremendously. The initial participant count was supposed to be 30, but only 23 people participated. I was truly shocked by this because we offered a gift card, extra credit, and yogurt for a week to college students. I thought by offering all that, surely all the students would jump on the opportunity. However, I was wrong. But I was also very thankful for the 23 students who did participate. There was one point in the process where I was very stressed out about how much the antibiotics would cost. The total I was calculating kept coming out to over $1,000 when I would add it up. Turns out I was calculating the different dose. I was supposed to be calculating the working dose of antibiotics. So my mentor and I only ordered 2 antibiotics because we were trying to lessen the cost. However, we realized the calculation error after purchasing the antibiotics and realized we had ordered way too much. The lesson learned here was to double check calculations always. It is also important to have an outside source, someone not involved in the research particularly, to look at the calculations to avoid making these mistakes. Dr. Rhodes said that her future classes will utilize the excess antibiotics, therefore nothing will be wasted. The first day of the experiment arrived and everything went smoothly. There was one thing that was not so smooth on my first day of pipetting, however. My thumb was so sore the day after all the pipetting I did. I was in the lab for over 4 hours pipetting a mixture of TSB and antibiotics into the well plates for all 23 participants. Talk about tedious work. I have a newfound appreciation for people who can pipette for long periods of time. Not only was it tiring, but it was also tedious in a sense that you have to pull up the solution just right. It is important to not have bubbles because the bubbles will take up the space of the solution, which makes it to where the person transferring solution would transfer less than desired. This can cause issues with the absorption readings. After the participants wrapped up consuming their yogurt for a week, I obtained a saliva sample from each of them to conduct the post-test. Dr. Rhodes came up with a better game plan for more efficient pipetting. I added the TSB to each well, and she added the corresponding antibiotics to the respective well. It was like an assembly line, and it saved so much time. One thing I have learned during this experiment is that there are so many ways to do things. Scientists generally find the most efficient ways to execute them. So I'd just like to wrap this up by saying this has been such a wonderful learning experiment. I feel honored to have been able to get in the lab and perform a true experiment. Most college students don't get to experience things like this. I was able to start an experiment from scratch and execute it based on things I thought of with the help of my mentor. I learned how to autoclave instruments before and after using them, how to pipette correctly, how to perform a serial dilution, how to read a well plate and interpret the results. I am thankful, so thankful for the honors program for this. I was nudged to get out of my comfort zone, and I am very glad I did. I learned many things in this process about myself that I did not know before. There were many ups and downs during this time with outside obligations still taking place. The students have to write an essay to get an interview for honors program, and I remember mine being an essay about a time I faced adversity and overcame it. I know that some graduate schools ask this question. I would say that talking about my senior thesis project is not out of the universe when considering how to answer that question. I would say that all students who go through the honors program and complete a thesis have faced adversity. It is a lengthy process that requires dedication and motivation. Also, this is a unique time in history that we are facing right now with COVID-19. No one would have ever thought that all colleges around the United States would have to move classes to online format. But here we are. We are all living in a time that will go down in history. I must admit, it has been hard to commit to writing a thesis when I do not have to go to traditional class. Since we moved to online classes, I have worked more hours at my job. It has been hard to find the motivation to do any schoolwork after coming home from a long shift. Although there are times that I lack dedication and motivation, I think of how far I have come. The end goal is too important to me to let laziness get in the way.